Okay, so this is a homework problem. Somebody did it, and I said, well, did you check? And wasn't quite sure how to check, although the work all looked good. It looks like it ought to check, but then when I tried to check it in my head, well, it could have been my head. Didn't seem to check, but we'll see. Okay? Because you got to know how to check these. You don't get immediate feedback, especially on an even numbered problem, if you haven't checked it. Okay? The back of the book tells you often whether you got it right if it's an odd problem, but not for even problems. You got to know how to check, and that's really important on a test. If you don't check your answers and they're wrong, I'm much less lenient than if you do. Okay? Depending on how badly you're wrong and so forth. All kinds of variables. Okay, so the B prime B matrix, you put the vectors in the columns. Now we've been over why, what these matrices mean and so forth. I'll let you read the book and see why you do this in terms of what we already know. Okay? And you really want to try to dig that out. But right now we're just going to use the magical method that your book tells you to use. I don't much like magical methods, but sometimes they're necessary, and it's kind of a point of reference that you can do this. Okay? So there's the matrix. Now, according to the paper I'm looking at here,
wait, shouldn't the negative 4, 4, shouldn't that be 3, 0?
Well, the B prime matrix is going to have a negative 4, 4.
Yeah.
Is that right?
And then the other one, shouldn't it be?
Yeah, I got that one wrong. It should be. Where did I get negative 2? Yeah. Got to pay attention to where I'm looking. It's negative 12, 0. But that's already there because we need to be doing that matrix. Okay, I'm not sure what I did. I don't even remember what I had written. But it should be 1, 3, and negative 2, 2. Negative 2, negative 2. Okay? Okay, so this reduces, according to the paper I'm looking at, to this. Okay? Meaning, if you multiply a vector according to one basis by this, you get that vector according to the other basis. But we have to understand what that means. What does it mean to express a vector in terms of a basis? Well, we've been talking about that for a week, so hopefully it's starting to sink in. But it's, it's not a trivial concept. Okay, so we're going to call that, this picture says that this is a transition from B to B prime. And somebody's talking really loud. That's my buddy Ben. He's a good guy. He's close to the door. Okay. So here's a transition from B to B prime. So we can already check this. Okay. So let's just check the vector 2, 3. B. What does that mean? It means 2 times the first vector in your basis plus 3 times the second vector in your basis. And the arithmetic is easy, so I'm going to screw it up, so check me. But it's going to be 2 minus 6, which is negative 4, and 6 minus 6, which is 0. Okay? Now, if this is the transition matrix for B to B prime, then your transition matrix, negative 1/3, 2/6, 3/4, negative 1/2, multiplied by 2, 3, is going to give you the matrix, or the vector, with respect to basis B prime. Okay? I'm abusing notation a little bit, but I'm going to go ahead and do it anyway. So, negative 1/3 times 2 is negative 2/3. 2/6 times 3 is 1. 1 minus 2/3 is 1/3. I think. Okay? Then 3/4 of 2 is 1 1/2. Negative 1/2 of 3 is negative 1 1/2, right? So it looks like that gives me 0. And that's going to work out. So it looks like what's that? That's 1/3 times negative 12, 0, right? Plus 0 times negative 4, 4, which equals negative 4, 0. And isn't that amazing? I mean, not so much amazing that it works out the way it's supposed to, but that I did the arithmetic right. Okay? So this ought to clarify what it means to express a vector relative to a basis. And this is central. You have to understand this for the rest of the course. Okay? Now, in addition, you could reverse these and reduce it to get the inverse of this matrix, right? Of course, it's easy to do the inverse of this matrix anyway. Okay? So, one way or the other, you're going to get the inverse. Okay? So if this is P, then it is important to put that dotted line in there, because when I first looked at this, I didn't know what the problem was. Just out of clear blue, I see a 4x2 matrix. So I'm thinking, well, you can't have a basis, you know, so this can't be a basis, so apparently we've got some kind of transformation from R4 to R2. So I'm in that context because, you know, just conspiring to confuse me. Okay, that's what it, you know, that's obviously what's going on, but you're carefully disguising it. That's not really what's going on, but again, you want to express these things as correctly as you can in the conventions that people expect, so they know what they're looking at without having to read a paragraph. Okay? Of course, you kind of want that paragraph to be there just in case they need it, but you got to have it both ways. Okay? And if you're not going to write the paragraph, you better really follow the conventions. And this is important. It's going to be very important, because I'm going to ask you to be doing more and more sophisticated stuff. And if you're not basing it on really clear thinking, and this really helps to make sure your thinking is clear, having the right notation, then you're going to be less likely to get things right and do things. You're not going to be able to do as much. Okay, so anyhow, if this reduces to IP, then this has to reduce to IP inverse. Well, when you reduced it, what'd you get? You got some 6s and 4s and stuff. What were they?
6494.
Again?
6494.
6494. And you were pointing, so I knew which were you give me rows or columns. That's good. See, that's what I mean by documentation. Now, if my peripheral vision was just a little worse, it might not have worked. It worked. Okay, sounds good. Okay, so anyhow, is this the inverse of this? Well, I multiplied the first row by the first column, got 1, right? And I multiplied the first row by the second column and got 0. So I'm pretty well convinced it is, but I didn't do the second row, okay? But these are in the ratio of 3 to 2, okay? And one of them's negative, okay? So, you know, a 3 to 2 ratio would give me a 0 here if one of them's negative. It probably gives me a 1 here. So I kind of believe it. Plus, you know, the person that did this usually does a row reduction right. So I'm fairly confident it works, but you understand how you would check it. You would now check I'm just going to do this. Times, and this goes from, this should go from B to B prime. So if we do this times one-third 0, which is the matrix we got for this one, we should get this, right? And you maybe want to think about why. I'm not going to go into detailed explanation because I probably have to write it out. But if I do this, I get 1/3 of 6, which is 2, and 1/3 of 9, which is 3, and it worked. It has to. There are all these consistency checks that you can do when you do a problem like this, and they don't take very long. Okay? So you want to do that. That's how you would verify a problem, okay? And you think about how you would verify other solutions. What has to happen to your solution? You know, what has to be consistent? So there we have it, okay? And that is the process, the superstitious magical process where you put the two bases here. And if you're a little confused about whether this takes you from B prime to B or B to B prime, you can check it, okay? Because it's easy to get that backwards if you don't understand totally why you do this. Now, if you understand everything that we've done up to this point, you can understand why you do this, okay? But that's, you know, that's a little deeper level of understanding. This is adequate. If you can do this, well, it means, if it means that you don't totally understand everything we've done, it means if this is all you can do, there's probably something else I'm going to ask you that you're not going to be able to do. But it's not going to be 80% of the test, okay? It's going to be something that separates the A's from the C's, or the B's from the C's, or the A's from the B's, okay?